this video is going to have a look at some different biological rhythms then. So the last video we looked at circadian rhythms, and now we're going to look at infradian and ultradian rhythms. So on your AO1, they are the two keywords that are on your specification: infradian rhythms, ultradian rhythms. So you need to know these both in depth. What they are there studies to support these? So we're going to look at the AO1 first. And then we're going to get the key definitions down. So remember, if there's a question in the exam, you can get a definition in there straight away. Usually that's a nice easy mark. So ultradian rhythms have a period shorter than 24 hours. And we've got basic rest and activity cycle and our sleep-wake cycle that fall under ultradian rhythms. We've also got infradian rhythms. Okay, these have a period longer than 24 hours, such as the menstrual cycle or seasonal affective disorder. So we'll look at infradian rhythms first, and we're going to have a look at the menstrual cycle, because that's one of the most famous or well-known infradian rhythms. And this is governed by hormone changes, okay, that affect and regulate ovulation. And the menstrual cycle refers to the time from the first day of the period, so when the womb lining is shed, to the day before her next period. Okay, so that is the menstrual cycle. And it's typically anywhere from 24 to 35 days. So you can see this takes a lot longer than just 24 hours. And ovulation occurs, so eggs are released, when estrogen levels peak. Okay, and that usually lasts for somewhere between 16 to 32 hours. Okay, so you can see for someone who's trying to get pregnant, for example, there's only a very short window within each month in order to get pregnant. So here's a diagram of the menstrual cycle. You wouldn't need to know this, but it shows you in diagram form what we're just talking about. So you've got day 0 here up to day 28. And it shows you how estrogen levels change here, blue line through the cycle, how the lining changes, so from menstruation, lining of the womb grows. So you've got this menstrual cycle, which is the most famous infradian rhythm. And there are research studies in this particular area. So although the menstrual cycle is endogenous, the fact that it's internal and affected by hormones, so inside our body, there is evidence that it can be affected by exogenous factors, so external factors. And McClintock did a famous study in 1998 where he found that menstrual cycles can be synchronized. Okay, so you might have heard before, if you have a big group of women all living together, that their periods will synchronize. Okay, they'll all get their periods at the same time. And there is research support to show this actually occurs. There are 29 women, all with a history of irregular periods. Okay, so their periods weren't the usual 28 days to 35 days. They changed every single month. And what he did was he took samples of pheromones. The pheromones are basically hormones that are released in order to attract mates. Okay. So he took samples of pheromones from 9 women at different times in their cycle. Okay, so he placed a little cotton pad underneath the armpits of these 9 women at different times in their cycle and collected pheromones from them. Right, now the study starts to get a little bit weirder. The pads were worn for 8 hours. So if you're one of those 9 women, you'd wear the pad for 8 hours to ensure the pheromones were on there. And then those pads were rubbed onto the upper lip of the other participants. So the other 20 participants had one woman's pheromones rubbed onto their upper lip. So, to give you an example of how this worked, on day 1, 20 women were given the pad from day 1 of the odor donor's cycle. Okay. On day 2, they were given the pad from day 2 of the odor donor's cycle. So they were given the pad to correspond with that day of their cycle. Okay, and they found that 68% of women actually experienced changes in their cycle, and their cycles were brought closer to the odor donor. So the person whose pheromones were put on their upper lip, their cycle, their period, became closer to that person's. Okay, so it shows that there are external factors that can influence infradian rhythms. It's not just all about internal factors. So another infradian rhythm is SAD, or seasonal affective disorder. And what that is, it occurs during the winter months. Okay, and it's characterized by things such as low mood, and you lose interest in activities and life. And it's an actual classified mental disorder. And it's known as the winter blues because people associate it with being depressed during the winter time. And the reason it actually occurs has been found to be because there's less daylight in the winter months. So during the day at night time, we get this hormone called melatonin released, and that's what gets released until we wake up in the morning. It makes us feel tired and drowsy. And the lack of light in the morning during the winter, so as you wake up in the morning, it's probably really dark. That lack of light in the morning increases the release of melatonin in the winter. And as a result, increased levels of melatonin also result in reduced levels of serotonin. So as well as feeling more tired, you're also feeling less happy. So it has a little knock-on effect there as well. But again, you can see it's an infradian rhythm because this doesn't just occur over 24 hours, it's much longer than that. And it's often linked to the onset of depression. It's linked to this lower serotonin levels. So people with seasonal affective disorder may develop depression. So, this is an example of a circadian rhythm, okay, SAD. It is an infradian rhythm, but it's also a circadian rhythm because it occurs in a cycle. Okay, it'll happen once a year in those winter months. In the winter months, it is circular circadian rhythm. So we look at ultradian rhythms now. This is slightly different. This is where it happens within 24 hours. So the sleep cycle is the most researched one. And based on research, and there's been so much research done on sleep, we know there are 5 stages of sleep. Okay, that occur over about 90 minutes. I'm not saying your sleep lasts 90 minutes, but these 5 stages occur within the 90 minutes. The cycle continues throughout the night. So the first 5 stages happen within 90 minutes, and then they occur over and over again. And we monitor this using EEG, and you should remember what that is based on previous video. So let's have a look at the sleep cycle then. So stage 1, you go to sleep. This is a light sleep stage. Okay, you can easily be woken up. It's when you first start nodding off. And it's where your brain waves start to become a little bit slower. Then we move on to stage 2. This is where your breathing and your heart rate start to slow a bit more. Stage 3 is when you start to experience deep sleep. Okay, your brain waves start to slow down even further. 4, you get into a state of very, very deep sleep and you produce something called delta waves, which I'll have a look at in the next slide. Stage 5 is REM, or rapid eye movement. Okay, and this is where brain waves start to speed up. You'll be able to see them on an EEG. And this is the stage where we see dreaming occurring. So if you've ever seen someone asleep and you see rapid eye movement, right, that's them actually in the REM stage and they're most probably dreaming. Here, you've got stage 1, so our brain waves are starting to slow down. We move into stage 4 here. You've got these delta waves, so peaked waves. And finally, you get into this REM stage of sleep, okay, where we're getting far more rapid brain waves, and our brain waves start to speed up, and this is where dreaming occurs. Okay, so you've got these 5 distinct stages of sleep that take place. Again, the brain waves you can see distinctly different. Stage 3 and 4, we've got these delta waves are very, very different to, let's say, the REM stage where we've got very, very fast brain waves occurring. Okay, so stage 1, they're starting to slow. Stage 2, they're starting to slow as well. Stage 3, you've got your delta waves. Stage 5, we've got these rapid brain waves for our REM stage. Okay, so these are how the brain waves change in ultradian rhythms. So there's been further research conducted in this particular area and suggested that we move through a similar cycle of alertness and fatigue during one day. So there's certain points where you're more alert, certain points where you're going to be more fatigued. For example, a lot of research has found that we can only concentrate for 90 minutes and that after that we start to lose concentration and begin to feel tired and fatigued. So we only have a 90-minute maximum concentration. So remember that when you're revising, don't do hours and hours and hours like I know some of you are going to do, 5-hour sessions, such diligent pupils. But you should be spending much shorter amounts of time and then have a break. And this has actually been termed our basic rest activity cycle, so our BRAC Right, let's have a look at the area 3. So we've looked at what infradian, ultradian rhythms are. Now let's look what we've got to support this and any real-world applications. So some people have suggested that there is an evolutionary basis to the menstrual cycle, and that it's actually advantageous for women to menstruate together. So if we think from an evolutionary point of view, if we had women who were all pregnant at the same time, then newborns could be cared for collectively. If everyone had a child at the same time, they could take it in turns in looking after the children, and therefore increasing the chances of survival. However, other people have argued that the opposite could also be true, that if there are too many women all cycling together, all on their period at the same time, all ovulating at the same time, then there'd be far more competition for the highest quality males. Okay, so females would be competing with females when they're ovulating for the highest quality males in the group. And therefore, that would probably result in certain women killing other women in order to get a mate. So it might actually lower the chances of survival. But that's up for debate. Does it have an evolutionary base or doesn't it? There's a methodological issue in a lot of those synchronization studies. There have been a few done that show that females synchronize. They were very early studies, and a lot of variables that affect the women's cycle, such as stress, diet, exercise, things we know affects the menstruation cycle, weren't controlled for. And the changes in McClintock's study were probably no more than we'd expect to see by chance. There were women on irregular periods and irregular cycles, so the fact they changed or went nearer someone, we may have expected that to occur anyway. And also, it was a small sample of women, which is obviously an issue with generalising the findings, and they self-reported their own cycles. Some may have not been fully truthful when actually recording when their cycles were. And to be honest, most other studies have failed to replicate McClintock's findings. So there is the issue of, are they actually reliable findings, or was this study actually valid enough in the first place to provide repeatable results? So there is research support for the stages of sleep. This is a highly researched area. And one particular study used EEG to measure the stages of sleep. And they controlled for things we know affect sleep, such as caffeine and alcohol. And what they did was they found that the REM stage, that fifth stage, the rapid eye movement, was highly correlated with dreaming. And the more active the eye movement, the more vivid their dreams were. And when you wake someone up during that REM stage, they could vividly recall what they were dreaming about. So, this finding has been replicated on a number of occasions. So, it shows us that there are different stages of sleep. Okay, the brainwaves are linked with different parts and different things that occur during the sleep cycle. There's also a practical application to a lot of this research, especially when we're looking at seasonal affective disorder. So the most effective treatment for this is something called phototherapy. And we give the person with SAD a light box. And they will look at the light box, which emits a very strong light early in the morning and in the evening. And what that does is it resets their melatonin levels. So remember, melatonin, because of the dark mornings, usually gets increased more. But as soon as they're given that light box with that strong ray of light, then melatonin will stop being released. Okay, and it does relieve symptoms in up to 60% of the patient. So it is an effective form of treatment. When we're looking at research for BRAC, there's pretty much only anecdotal evidence out there. A lot of it lacks the scientific rigour that we'd expect in an experiment. So we can't conclude, therefore, that a biological rhythm lasting 90 minutes is definitely present through this evidence. Okay, so we said before, you can't concentrate for 90 minutes, then you feel fatigued and tired. Okay, we can't say that based on the evidence. There is one study that involved some prodigious children, so highly talented violinists, and Erickson found in this study that the best performers would practice for 3 sessions a day, and each of those sessions would last for 90 minutes. And it does seem to indicate there is some sort of ultradian rhythm, that we have a 90-minute period where we can concentrate for the longest. However, these aren't typical children, okay? They're exceptionally talented violinists. So it doesn't mean that it's going to be true for everybody else. So there is very, very little evidence in this particular area.